Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Okay, step on inside, and we've taken about 10 days or so off from some videos, but we're going back to some trig again, only now we are graphing trig functions, and today it's going to be on sine and cosine graphs, and we are going to hit the whole kit and caboodle, or however you, kitten, caboodle, kitten, whatever. We're going to do the whole thing with them. Any sort of transformations that we have, whether it's changing its vertical stretch factor, horizontal stretch factor, vertical and horizontal translation, you got it all with those things. We might be reflecting them as well. Now, we won't be saying those terms, though. We'll be using words like amplitude, frequency, midline, things like that. A little bit different there. So I'm going to dive into that. I guess I have to graph the parent functions as well now that I think about it. Probably got to do some of that. Might start off at a little slow, and then each time we hit a new parameter, I might start off a little slow. Other than that, these go kind of fast once you start to really get the gist of what's going on, or at least I'll be going pretty fast in that way. And you got to be careful if you're looking at these graphs with me, because sometimes the scales can change, or sometimes they won't be used as much as they want to. Now, there's a little hiccup with these that I don't particularly love, and you might see me rewrite these along the way. I will have to rewrite some to get them into the proper form that we're going to try and get. But like this one right here, we're using theta. There's nothing wrong with theta. I just tend to tie theta in with degrees. And I like to use X when I'm talking about radians, and I always like to use the parentheses around things as well. So if you see me rewrite this, I might say like y equals sine of X plus 1. Hey, both the same thing. My OCD's kicking in, or something that you, outside of CUDA software, you would generally see here. Okay, we're going to graph each function and its midline, include points for peaks and troughs in the window range. So I'm going to first graph, here's y equals sine of theta plus 1. Before I do this problem, let's just look at y equals sine of theta and see what, sine of x, and see what this thing is all about. Every time, now listen, this has a pi over 2 right here, so every increment here's a pi over 2, which means every increment here's a pi over 4. This is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, etc. Anytime you hit sine of a pi over 4, it's a root 2 over 2, or negative root 2 over 2. That's around 0.7-ish. Anytime you hit sine of pi over 2 or sine of pi, it's a 1 or a 0. So if you, I'm just going to do this fast here. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. And there's a 2 pi right here that we don't really see. I'm going to include those points each time that it matters, and it really does here. And if I do sine of negative pi over 2, that's coterminal with sine of 3 pi over 2. So that's also negative 1 here. And then we kind of go back and forth. Well, you're going to see this oscillating pattern. Now, the reason I mentioned the pi over 4s is because this is not this. It's not straight lines and jagged edges back and forth. No, there's a progressive increase and decrease. And although we don't get all the points in between the pi over 3 and pi over 6, pi over 4 is around 0.7-ish. It gets a little more up here. And then we get to, 0.7-ish here, and negative 0.7 and negative 0.7, etc. That negative root 2 over 2 and positive root 2 over 2. Point being, and I'm not going to plot these each time. This is just now. Point being, there's a little more smooth action going on here. And that's what's going to happen each time. There's more of a progressive increase and decrease with these things as they hit these points and smooth out and go into them. That's important to note. You're going to see my drawings try and attend to that kind of precision as well. Anyway, this is your sine graph, and this is not sine of x plus 1. What I can actually do is I can just do a vertical translation of this, because that's all that this one is. But as I keep kind of talking about this, let me draw this in red this time. Actually, that's not bad if I do that for the most part. Actually, I'll do green. This here is what is called your midline. The midline is the, there we go. The midline is the, well, it's the middle of your graph value. You can see that we oscillate up and down 1 unit each time from the midline here. So that midline's that middle part right here, and the midline would either shift up or down based on you having a k value, and we'll talk about that in a bit. But that one's the midline right there, and now I started here at where I'm taking the sine of 0, and that's where you generally want to start. Where are you taking the sine of 0? Even if there's a horizontal shift, where do you take the sine of 0? And that's where you'd shift that thing. So sine graphs start on the midline because the sine of 0 is 0. And if your midline is up, then you start up on the midline with it, etc. Now, other words that I'm going to have come into play right now before I actually jump into the official graph of this one and all the ones thereafter is there is this thing called amplitude, which is distance from midline to this peak right here, or distance from midline to a trough right here. That distance is 1 in this case. That happens to be this value that we don't see right there, that being a 1. There's a lot more I could put within. The plus 0 has to do with the midline being at 0 right there. But there's stuff inside the sine function you would use as well, which is how we change the frequency and the period and how we horizontally shift. And you've seen horizontal shifts with my videos before with that h, with the hk thing, the minus h portion. That's going to be involved. Not yet, and I think not till later. But you're also going to see a b value down the line later. We're not doing it now, so I'm not going to talk about it too much now. But I want to mention a word here, which we have to see each time, which is the period of this graph. This graph, as you can tell, from here to here and from here to here, repeats what it does. This is one full period of your graph right there. And here's another full period of your graph right there. And it would repeat this over and over again. It oscillates. And every period has a wavelength of 2 pi units right there. Every 2 pi then repeats itself because of that coterminality aspect. That's what sine graphs do if its frequency doesn't change. Right now this frequency is just 1. It takes 1 period to complete a full cycle. It takes there's 1 period within a 2 pi period. So anyway, I know that's a lot of different words there, but you're going to kind of hear about that 2 pi thing each time. Just make sure that you know that every pi over 2 units, we should be hitting another critical point here. A peak, a midline, a trough, a midline. And in between, I won't plot these points, but just understand there's that curve happening there. Okay, so let's officially do this one, the y equals sine of x plus 1, or sine of theta plus 1. Now, it's going to be the same thing as these before. Let me write this up above. Our general equation will look like this. A times the sine of, and there's going to be some garble in here, x minus h plus k. We've seen a lot of this before. A is a vertical stretch factor, and in this case, it will also represent our amplitude, the absolute value of A. If it's negative, we'll flip this graph over. HK is your horizontal vertical translations. Like I said, K represents your midline. A is horizontal. We'll get into that later. And B represents the period. And notice that it has to be factored out. And that's something else in these graphs here, too. The equations, they won't be factored. So we're going to have to factor them out if we want to reveal the true H value. Okay, anyway, so this plus 1 that we have on this official graph right here, what's this going to mean? It means this graph is going to be shifted up 1 unit. So this graph instead should look like this. And I'll go ahead and just cheat on this one and just do exactly that. So what this graph does is instead what we'll do in future graphs, we'll start on the midline. We'll start on the midline right there. Excuse me, we'll draw the midline and we'll start on the starting point there whenever you're taking sine of 0. And then you go every pi over 2 units to hit a new point right there. And you continue on that midline. You can see it goes as high as 2 and as low as 0. The amplitude is still 1. And that's it. All right, cosine. If we look at y equals cosine of x briefly before we do the minus 2, as you can imagine, it's going to be shifted down 2 units, not much from there. Let's start with that midline, as I'll kind of do in the future anyway. So this is at 0, y equals 0 to start. Now, cosine graph has the same oscillating pattern as sine, and it has the same wavelength and amplitude and everything else. The difference is its starting point. You see, sine of 0 is 0. And listen, I'm not spending time talking about on why those things are, the things you either know or not. Cosine of 0 is 1. Cosine of 0 is 1. Instead of starting at the midline, you start at its peak in this case. You start up there. Cosine of pi over 2, cosine of 90 is 0. And then cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. You can see the oscillating pattern, but it starts at a different spot. It's almost like a sine graph if it was shifted pi over 2 units to the right or to the to the left. If the sine graph was shifted pi over 2 units to the left. So, there's an equivalence that you can see there as this graph does the same thing, but in this format here. Same graph as the sine one. No change in that, right? And I always want to draw arrows at the end of these to indicate that it does something here, but it does go back down, right? It doesn't go back up from there. Cosine is also called an even function. Sine is also called an odd function when it's just the sine of x and stuff. So cosine of x is like that, right? Same thing. Amplitude is 1. Wavelength is 2 pi, right? It went from 0 to 2 pi before it repeated what it's going to be doing again. The frequency is 1, all that kind of stuff. It does all the same stuff there. Now, what's cosine of x minus 2 going to be? Well, it's shifted 2 units down. So last time I'm going to be cheating, at least for the vertical translations, and that would be that graph right there. So that's what those graphs look like. That is what they do. We move on forward. All right, numbers 3 and 4 have a new A value. Now, if you refer to A, once again, it is a vertical stretch factor. However much this went up and down before, you're going to multiply by that amount and change that. This amplitude of 4 means these will go up and down 4 units from the midline instead of up and down 1 unit from the midline. So this one would have a midline once again at y equals 0. This again, I'm probably going to be OCD on all these here, so I'll go ahead and write this out. Y equals 4 times sine of x. So a sine graph, and by the way, these always change: sine, cosine. Get used to that. That's good variation for you. A sine graph starts at 0, or sine of 0 is 0, I should say. It starts on the midline. Pi over 2 units, I hit my peak. Now my peak this time is going to be 4 up. That's a change in my amplitude. Pi, sine of pi is 0, hits my midline again. Psi of 3 pi over 2 is negative 1, times 4 is negative 4, and back. So it should be the same as the original sine of x graph, but just 4 times taller than the other ones there. And that's what's happening here. And, you know, sine of 4 times sine of pi over 4 would be around 2.8-ish, or probably around there. But instead of 2, right, it's not straight up and down, or it's not linear. It has a little more of a curve to it, you know, like this. And that's something that you'd like to embrace when drawing this. You won't be perfect with it. Just don't, that's probably a little too steep. Just don't make it linear, right? And I'm probably over-embracing it. It should have a little, and I'm probably being too particular. I have a lot of graphs to do, guys. There will be 24, I think, total. But, you know, this is what this thing is going to do. And yes, I'm going to complete the entire window range for all these graphs that we do. That was a little too linear for my taste. Like I said, once I figure it out, I'll kind of change form. That's fine. Okay, and we're good. Okay, y equals 1/2 times cosine of x. I just can't sit with that theta. Anytime I see theta, I'm thinking degrees, and I don't know if that's necessarily true. I don't know if that's necessarily a true thing that'll happen. All right, midline is once again at y equals 0 because reasons. No, because there's no plus k going on right there. We'll see a plus k again in a moment. Okay, so now the 1/2. Now the unfortunate thing is they don't change your y scaling here when it comes to window range. This still goes up by 1, 2, 3, etc. Now cosine graph, cosine of 0 is 1, right? But instead of going up 1, the amplitude's no longer 1. The amplitude is now 1/2. So now we're just going to take half the height of before. So halfway up. What's halfway up from 0? It's still 0. Halfway down from negative 1 is negative 1/2. So you can see that it's got shrunken action here. Like I said, it would be nice. I get it. I get when we don't change these things that you do want to see this actually be shrunk. Otherwise, it looks the same as all the other ones. But it makes it harder for us to graph. So there's that as well. Otherwise, you're right. People do get confused. But I'll tell you what. This thing is going to change at times because I didn't make these window ranges, right? It's based on the problem. When the frequency starts changing, you are going to see these things not go by pi over 4s anymore or visible pi over 2s. You're going to see them going by different values. I tried to make sure I only picked problems that we could find them right on these points here. But this is just an example of that. Okay, so there's that graph there. This is literally half that height-wise of number 2. And it's not shifted at all. All right, numbers 5 and 6. These are pretty similar-esque. What's going to happen here? This time we're going to start at a different midline, though. This midline is going to be at y equals 2. So here's my version of what I want to write there. Y equals 2 times sine of x plus 2. We draw a midline at y equals 2, and everything will be in relation to this because it's vertically translated. Sine graphs start at the midline. This is an amplitude of 2. So at pi over 2, instead of being 1 up, I'll be 2 up. And then I'll be 2 down and hitting back. And again, these don't really change. I mean, once you understand something about your quadrantal angles here, you can see how this pattern goes. And, you know, at some point, it almost becomes busy work. It's like, shoot, now I just got to make sure I got a good-looking curve, right? The points are pretty easy to find. There are in-betweens, right? From all those special angles, we know a lot about sine of, and I'll show you. Actually, these have different amplitudes, but I'll try and show you. You know, sine of pi over 6 is 1/2. Double that is 1. So, you know, this point right here would be the equivalent of like, hey, this is pi over 6. This is pi over 6 right here. And that's, you know, that's going to be 1 up from there because 1/2 times 2. So, you know, there are other points you could find, but as long as you get the curve kind of doing the curve thing, then you'll kind of be in good company with me regarding those drawings. And 3 cosine of x plus 2. is very similar, only now the amplitude is 3, and we have a cosine graph, which means we start above this guy instead of on it, instead of on the midline. Amplitude is 3, so I'm going to start 3 above right there. And, you know, we'll move on from there. Pi over 2, we hit the midline, and then we go 3 down at another pi over 2 units over, and back up. And you can see this thing taking form. And these aren't too bad here. I mean, we're going to be doing some other things here in just a moment on these when it comes to the horizontal shifts. Actually, period comes next. And this one can throw people in a loop more so than the others because it's inverted from that stretch factor. And I'm talking over this problem right now because it's essentially complete. This is actually looking pretty good. You know what I'm going to try to do? Hold on. Let me try this. Let's group these. Oh, that was weird. Copy, paste. Oh! Isn't that cool? All right. I'm cheating. Cheating way too much. I know you can't do that there. Okay, so I was talking over the problem, but what I was going to mention as we move forward here, actually, let me copy and paste this. This is the general thing. Cosine has the same ideas going on. All right, there we go. So now we're going to start talking about B. B is this guy right here, and yes, this 2 is that B. This is where I really do want to start writing these a little more. Y equals sine of 2x like that. So there's no minus h involved yet, but there is a B value. Anything that you're doing inside the function is something that happens before the function occurs. Same with the h and same with the b and stuff. The question is how they affect x to the point that you choose a different x to counter what's happening to it. A lot of words. The thing is, we see this minus with h, and you know that it's kind of opposite of what we do. If it says minus 4, then you go 4 to the right, not 4 to the left. Well, b is the same thing. As we multiply by x here, think of its inverse thing. If b is 2, like this one, remember, this has to do with horizontal changes, compressions, and stretches. We don't stretch this thing out 2 times horizontally. We compress it 2 times horizontally because we have to ask what values of x we plug into normalize compared to that of y equals sine of x, right? If I wanted to take sine of the same value, let's say sine of pi, this x would just be pi. This x would have to be pi over 2 because when you times it by 2, it gets pi out. So you have to take half of what it was before in order to counter its effect. So that's something you have to be careful of. So this 2 is, it's not your period, it's your frequency. The frequency says, and I'm going to do more with this calculation-wise. It'll kind of help you recognize what to do. The frequency says how many times your graph completes a full cycle within the default 2 pi period wavelength. Generally, your graph would hit... Oh, and notice this thing's stretched out. Notice how this thing's stretched out. This is pi over 2 and pi right there. Well, anyway, but normally your graph would do this. Okay, whatever. Now your graph is going to be doing half that. Here it's going to hit and whatever. It's going to take less time to complete a cycle. So here's what I'm going to do for the most part, just to kind of emphasize what this thing is. The period, I don't want to say the word frequency because that's the other thing. Period, a sine graph's period is inversely proportional to its frequency. The larger the frequency, the smaller the new period. The larger the period, the smaller the frequency. Your general period is 2 pi, but when you divide it by the frequency, then you get what its new period is going to be from the default. And this is true for cosine as well. Period is 2 pi over b. So what is your new period in this one going to be? It's going to be 2 pi over, your b value is 2. So this is pi. Your new period is pi. It'll take pi radians to cover an entire wavelength, where before it took 2 pi radians. Now, how does this help and hurt us? It doesn't hurt, but how does knowing this information make us change our things? If I divvy pi up into 4 different sections, because that's what I do, right? I hit a peak, I hit a midline, I hit a crest, a trough, I hit a midline, right? Peak, midline, trough, midline. When I do that, boom, 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 I'm hitting 4 different parts before I get to the coterminal section again. So let's splice this up into 4 things. How many increments, intervals does it take for me to hit a new critical point? Pi over 4 units, right? Pi over 4 per critical point. What I'm saying is instead of my graph going to pi over 2 to hit 1 and pi to hit 0 and stuff, we'll hit the pi over 4s. Now it's going to be pi over 4 hits here. Let me do this for real. Midline. And this, like I said, it's going to be slow this first time, and then I'll speed it up after. Midline. Sine starts at the midline. Instead of hitting pi over 2 to start, we're going to hit pi over 4 to start, because that frequency of 2 means the wavelength, the period, is half of that. So at pi over 2, see, sine of pi over 2 isn't 0, but sine of 2 times pi over 2 is 0, because that's sine of pi. Then we hit -1. You can see nothing else has changed on this. The only thing that's changed is just the 2. Everything else, the amplitude is 1 and all that jazz. So I hit as far as I can there, and we complete that on this other side. You know what I just noticed? And this is, I might have to explore it further. I don't know if any of these will be negative. And I'm referring to the, oh, that's probably what they were talking about. I probably had a customization option to allow for negatives, and I totally didn't. And now that I'm thinking about it, that might be a whoopsie on my part. I think what I wanted to avoid was having negatives inside the functions, which very well may have been my option, but I may not have any negatives, guys, on my amplitudes, on my stretch factors. Let me bring up what that is. If this was negative sine of 2 pi, the graph would have gone this way instead. It would have started down instead of up. I'm sorry if none of those show up. Now that I think about it, that there's a problem. I already distributed this to my students. I can't change it. Okay, so this is sine of 2x, and it's that graph right there. So again, the frequency works inversely proportional with period right here. You divide 2 pi, the default, by the frequency, whatever it is, and you get it. All right, y equals cosine of theta over 4, or the way I like to think of it, y equals cosine of 1/4 x. And I state that because you will want to factor out that 1/4 in future time, to know what it looks like there. It's whatever. You just don't want to think of it as a 4. You don't think of it as 1/4. So the period this time, see, this is going to be interesting. The period is 2 pi over the frequency of 1/4. How do you divide by 1/4? Well, it's multiplying by 4. 2 pi times 4, that's 8 pi. It takes 8 pi radians to complete a full wavelength of this thing. It's crazy. 8 pi instead of 2 pi. That's 4 times more, because the frequency is a quarter. You only complete a quarter of a wavelength within the 2 pi expected period. So that means if you divide this by 4, and get 2 pi, every critical point occurs at 2 pi for these things. Now, there's no vertical or horizontal shift for this thing, so the midline is once again at y equals 0. This is a cosine graph, so I'm going to be starting above this thing at 1. There's no amplitude change here. But what's going to happen is it takes 2 pi units. The full wavelength is 8 pi. The full period. It takes 2 pi units to cover a next critical point. And the scale is there for us, right? It's going to help us here. But hitting 2 pi is where I hit this midline here. Because again, what is 1/4 times 2 pi? It's pi over 2. Cosine of pi over 2 is 0. And that's where we're getting that. Another 2 pi hits us here. Another 2 pi hits us here. We don't even get to see the full wavelength from this starting point all the way to 8 pi. We don't get to see it take form. It's too big, even for our scale. But this one does go back down this direction. We get to see a full wavelength somewhere. I can see a full wavelength from, like, say, here to here, for example. That's 8 pi units. But that's as best as we can get for that. And let's go ahead and construct that function. And again, the scale changed for us. The graph itself, this window range, it changed its scale for us there. Okay. That's cool. So this will keep happening. Just because we have some shifts here doesn't mean that it's going to change anything. This is y equals sine of 3x minus 2, like that. So the minus 2 is your midline right there. So we're starting down there. Our starting point is on the midline right here. No horizontal shifts yet to speak of. That comes later. Okay, now this 3x here. Ooh, I don't know if I intended to have this one in here. This one and this one might be a little more difficult. I might want to change this. The period here, I think later I make sure these don't show up. The period here is 2 pi over 3. this is where things get a little tougher for me to speak on when it comes to the scale, because the scale is the wrong choice for me. So okay, this problem's going to have a little trouble for us. Okay, so first of all, it takes 2 pi over 3 for it to complete its full cycle. Now, where is 2 pi over 3? That's what makes this a little tough to talk about. I feel like I got to change. I feel like I got to change this problem. I probably will, even for the sake of my kiddos. I'll even tell them I got to change number 9 and heck number 12. Let me quickly see if there are other problems I got to change with that. I wasn't very aware of the matter there. Those are fine, and I think I made sure that one's fine. That one's fine, I think, and that one, I think that one's fine as well. Okay, so these ones I'm going to change a little bit. Hope you don't mind this. Where is it? 3. Let's change it to, we haven't seen 4. I'm going to go and change this one to 4, guys. Hope you're all right with that, because we got to get something else that's at least going to fit within realm. Even if it makes some things a little bit skinnier, at least here we can figure out where that is. 2 pi over 3 is a little bit more difficult to talk about because you got to know where the pi over 3's fit right here. A pi over 3 would have been, shoot, I don't even know. Would have been like here-ish, and then another pi over 3. It's going to be, if it's a third of the way over there, yeah, this would have been a little tough. 1, 2. Oh, man. I don't know if I could have said this really well. 2 pi over 3 would have been, let's see, what's this, 135? It probably would have been here-ish, I'd say, right there. And that's tough, because then you got to divide that into quarters, and then each of these quarter bits you would have had to hit something. Yeah, I couldn't have really spoken about that in a way that would have made enough sense, even for myself to explain nicely. All right, so 2 pi over 4, that is pi over 2. The period is pi over 2. Now, this is going to be skinnier, and that's fine. I'm totally changing this up. That's fine. It's going to take pi over 2 units to complete a full wavelength here, which means what happens when you divide pi over 2 by 4? When you multiply that by 1/4, that's going to be pi over 8. Every pi over 8 increments is another peak, midline, or trough of some sort. Now, where's pi over 8? Well, pi over 2 is just right here. So just think about this. We got to complete this whole set within that time. And this is essentially what your drawing is going to look like. I'm going to make it look better. This is essentially what your drawing is going to look like. That means right here, a quarter of the way to there, it's going to hit its peak. Notice your amplitude is still 1. And then it hits midline, and then it hits trough, and then it hits midline again. Right? So it goes boom, boom, boom. This is pi over 8. Right? This is pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. Sure, it's in between. Okay, that's fine. I'm going to live within in between. Now this keeps going like this. Peak, midline, trough, midline, peak, midline, etc. This is going to be a crazy looking graph. That's for sure. You know what? Pi over 3 would have been worse. Would have been a hair wider at the cost of having a lot of trouble finding its scaling. And listen, it wouldn't have been a bad graph if the scaling on this was set up for it. And I apologize for not having it set up for it. Obviously, it was designed by the problem itself. But it wouldn't have been an issue for us there if we did have that right setup. I'm trying to make this non-linear. And you know what? For the most part, I kind of am. I'm getting that curve aspect. It's not completely parabolic. It does have kind of a bit of a linear trend when it crosses through there. This isn't dreadful at all. This is about as much as you can get without getting overzealous on it and making it almost not a function wise. But okay, that's pretty good right there. I like seeing that oscillation. All right, let's keep moving forward. Oh, we do have a 4 right there. Okay, well, you know what? We're going to see another one of these. Okay, that's fine. All right, y equals cosine of 4 theta plus 1, or y equals cosine of 4x plus 1, just because. All right, plus 1 is our midline right here, right? Cosine doesn't start on the midline, but it starts 1 above, assuming no amplitude changes, which there are not. And you know what? There are no negatives, and I'm kicking myself over recognizing that now. Excuse me, that's just too bad. Now the period is unchanged. The period's going to be pi over 2, which means it takes pi over 2 for it to return back to its spot in a coterminal way, which means what's the in-between and all that kind of stuff. I mean, these are the kinds of things where if you get too technical in these formulas and stuff, you're probably going to get lost in the process. If you naturally understand this thing's got to complete this full period and come back up right there, then you know what this graph's supposed to do. You know that halfway in between here, it has to hit the trough, and halfway in between those points, it's got to hit the midline. if the complete cycle is getting back to its coterminal point there to finish this off, this is what it's going to do in between. Every pi over 8 units, it's going to hit another critical point. And that's what's happening here. So we're going to just keep on that. We're going to keep on trucking. We're going to keep on that momentum right there. And honestly, save myself face and time, I think I'm going to probably copy and paste the sine graph if it's all grouped as one. I don't know if it is. Oh, not quite. Oh, not even. Okay. I hate when I group it, it gets skinny like that, but that's all right. So I'll just stick that right in there. Why not? There it is. There it is. That probably took more time to do that than anything else. Okay, so there's that graph right there, cosine plus 1. All right, 2 more right here. I think before we hit some of the horizontal translations, which honestly aren't bad. I think what happens is they get bad when you have b with h involved. All right, so this has a couple of halves here. This is the a value. Let me rewrite this actually. It's going to be y equals 1/2 times sine of 1/2 x. And again, I stick the 1/2 out there in the case of factorization and such. This is your b value. B value is not 2. So, you know, your period here is 2 pi over 1/2, or 2 pi times 2. So that's 4 pi. So it's going to take 4 pi radians for it to complete a full cycle there. If you divide that by 4, that's going to be pi. The reason I keep saying divide by 4, see, the period is 4 pi, but every critical point is a quarter of each part, right? There's no vertical or horizontal stretch right here. We're just going to have it like, or shift, I should say. We're going to have the midline here. It is sine, so we'll start on the midline. The amplitude's 1/2, however, and you just got to know that every pi units, you hit your next critical point. Instead of at pi over 2 to hit your peak, you'll go to pi to hit your peak. Peak of 1/2. Midline is another pi units over for our trough. And then 4 pi, you know, I can imagine it's going to be right there. I'll go ahead and draw it. I don't want to lose that part. It's a part of it. It's a staple. That's the end of the period. Another pi units this way, and we complete this cycle like so. These graphs aren't dreadful. Got to know what you're doing with them. And I'll tell you what. And I don't know. Well, okay, first of all, I don't know if I have any videos on this at all. Maybe a review video for my pre-calc days. But that's my other what that I want to tell you about. I'll tell you what. I haven't done these in 5 years. Maybe 6. I got to think when I last taught pre-calc. It was either in 2016 or 2017. You know, probably the 2016, 2017 year. Might have been the 2015, 2016 year. I'd have to go back to my videos and find out what year that thing was. I haven't done these in forever. Haven't lost it. I haven't done these in forever. So there's that. I might have used different words. I don't know if I use midline and, you know, all that kind of stuff, but I am now. All right, this is another one I do want to change because they don't give me a scale appropriate with the pi over 3s. You know what we could do? We could change this to pi over 3. Let's be nicer on this one here because I don't want to change every problem under the, you know, thing. Now, if I change that to pi over 3, that means this becomes 2 pi over 3 right there. Hope you're okay with that. So negative 2 pi over 3. Okay, we won't change this problem. We'll leave it. We'll change the scale. And I'm good on that because I felt kind of bad for having this one be a little bit different and, you know, not knowing what to do. And there it is. All right, so we're changing that one here. We do have a couple things involved. There is also a vertical translation on top of all this. So, of course, I'd like to rewrite this as y equals 4 times cosine of 3x and then minus 1. Okay, so let's start with the midline. So we're starting at -1 for this midline right here. Let's get back to that idea of what that 3x is doing again. That changes your period instead of 2 pi to 2 pi over 3, which cannot reduce. Period is 2 pi over 3. That means that we complete our cycle after 2 pi over 3 in wavelength. And that's perfect for this one right here, now that I've changed those, right? Because you divide that by 4, which is kind of weird to talk about, but dividing by 4, look, here's my whole period block divided by 4. 1, 2, 3, 4, right? Every one of these increments right here, we're going to hit a peak, crest, or midline. Peak, trough, or midline. Crest is peak. So we're going to complete it then. And 4 is our amplitude. I wish I had some negatives. I'm going to go 4 up to start with at here. So 1, 2, 3, 4 up right here to start. And again, we're going to finish right there, right? The whole idea is it's going to go down and finish back up. halfway in between, we spoke about this, halfway in between it should hit its trough, 1, 2, 3, 4 units down, and in between we should be hitting them midlines right here and right here. Not making it any harder than that, really, and actually it hits the midline again over here if we can fit it, just to go back, and it's doing the same thing on this side. So, a little midline action as we hit peaks and troughs. So there we go. This will be the new when it comes to this graph right here. I hope that's all right. Changing the scale because they did not give us a fine enough scale for it. And I'm not going to sit around hunting for where pi over 3 exists in a series where pi over 4 and such is. It's too narrow. There are too many problems here. You're already having trouble kind of learning this stuff for the first time. And honestly, I didn't present some other things like negatives that I really feel like I should have been presenting here. And I always resent the fact that I can't change it now, either because I already started the video and or if you don't know me, I would have restarted this video. I would have redone this video entirely just to say, oh, I didn't include those. But I already handed out the assignment. So I can't change that. There are 2 problems I'm changing. I could change a problem here and there. I don't think that's a problem. I cannot believe I didn't realize that for myself. Okay, guys, we're getting into horizontal translations here. Horizontal translations. Now, this is the portion here where, copy, paste. This is the minus x minus h part. I'm not going to make this complicated. People know how to work this stuff out for the most part. The question is what happens when b gets involved in the next set of problems, which I think shows up, and that's where it gets a little tricky just to factor it out and stuff like that. But h, if it's a plus, remember it's backwards. If it's plus, that means we go to the left, and if it's a minus, that means we go, to the right. But that'll kind of be your starting point right there. That'll be where the new starting point goes. And you'll see that they even put this around parentheses for you as well. If I rewrite this, the only reason is to put an x instead of a theta, but it's inside parentheses already because they know that's what you're taking the sign of. So x plus pi over 4. Notice that is not your midline value. That's not your plus k. It's your minus h. So your midline is plus 0. There is no midline change. So we are just going to be at y equals 0 here. The amplitude is 1. There's no change on that. Now sine, we start on the midline. But we're not starting at 0 anymore. We're not starting here this time. This plus pi over 4 means what value of x would I have to plug in to take the sine of 0? We would have to plug in negative pi over 4, right? Negative pi over 4 plus pi over 4 is 0. So that's the x value that we're going to start at. We're going to start at negative pi over 4, which is just right there, because pi over 2 is double that of pi over 4. So pi over 4 is right there. Now the period appears to be 1. There's no change in period now. So, period is 2 pi over 1, which is 2 pi, which means it takes 2 pi units to get all the way to complete a wavelength, a full period there. If you divide 2 pi by 4, it's pi over 2. That means every pi over 2 units, you'll be hitting another peak and such. So this goes back to what we started with in the very beginning of the video. But now that you hear that, with a b value being 1, you might say, how does it work here? And that's how it works. Now, the difference is, I don't want to go to pi over 2 literally. I just want to go pi over 2 over. That's 2 pi over 4s. So right here is where we hit our peak. And then 2 more overs where we hit the midline. 2 more overs here where we hit a trough. 2 more overs where we hit midline right there. And I'll leave it at that. Other side, pi over 2 units over, pi over 2 units over, and we mosey on over. That'll be good enough for what we got going. As long as, I keep mentioning the arrow portion. It's not just arrows. Make sure this thing goes in the right direction where it's supposed to go here ultimately. I got to draw arrows after this. But let me show you what you probably don't want to do, especially on the left side right here. You don't want to have this thing go up right here and draw an arrow. It doesn't go past that, right? The maximum is 1. The minimum is -1. That's his peak and trough right there. That's as far as it goes, right? You don't go any farther than that. All right, y equals cosine of x plus 3 pi over 4. Now, I hope there aren't any other mistakes here when it comes to plotting things in right spots. This one shouldn't be a problem. This is, first of all, no vertical shift here. We got a midline at y equals 0. And cosine does start above. It does start above the midline. It starts 1 above, assuming no stretch factor change, which there isn't, no amplitude change. But we don't start here. We don't start here. We are going to go left shift 3 pi over 4 units. 3 pi over 4 units. 1 pi over 4, 2 pi over 4, 3 pi over 4. That's your starting point. The frequency is 1, so the period is 2 pi again, so there's no change in that. So every pi over 2 units, I will be plotting another point right here. So pi over 2, and we'll hit the midline. Pi over 2, we'll be hitting the trough. Pi over 2 back to the midline. Peak. There's a complete cycle of 2 pi radians right there. That's actually 2 pi radians. I'm starting, when it comes to Rust for myself, because I'm now thinking in my head how I went about, what it was? We had to create our own graphs. Yeah, we had to create our own window ranges. I was thinking about, when did I have to do things like get a common denominator and stuff to really work this out? Now I know. It's when we had to make our own graphs. I can't guarantee you I made videos on it, but I can guarantee you that that's something we had to teach and talk about and say, hey guys, you're going to make your own scales. I don't think I'm going to do that for my IM3 bunch. I think scales will be pre-made, and pre-made in a kind way. I'd even argue that the pi over 8, let me go back to them. I'd argue these are kind enough that you can get halfway in between. Those are fine. Once you get a pi over 3 with something like that, that's just cruel. But you would create your own window and say, what are those actual values they're hitting? That was pre-calc. I mean, there's a little bit more. You're going to be doing these again in pre-calc. They don't leave. You'll do more with word problems. I hope we get to do some word problems together here, even in video form. But there's that graph. All right. Let's add in another wrinkle. We got the amplitude here at the 1/2. Now here's that horizontal shift. There's no midline change though. This is at y equals 0. So this is a sine graph. So we will start on the midline, but we'll be shifted to the right 3 pi over 2 radians. Will be shifted all the way over here for a starting point. And when I say starting point, keep in mind, this thing repeats all the time. You just want a reference point that you know this thing hits for sure, and this is among them. Now your period is 2 pi still, so nothing changes as far as every pi over 2 units. You got to make sure you know where your pi over 2 units are, like this is pi over 2. Every pi over 2 units you hit another thing right here. And I know I go up because I didn't make any negative values here, so as long as you go right, the first point you hit is going up. I can't fit anymore, but this would have went back down here, which means we got to go underneath here as we go just backwards now. Pi over 2 units over, pi over 2 units over. Oh, I'm sorry. These are 1/2s. I'm sorry. I got to shrink these. Let me change that. But the midlines are the same here. So here we go. So this is 1/2. I was going to say, but there's some other change I got to do, and this was it. So pi over 2 units over like that. I hope I didn't miss any other problems where I was supposed to use a amplitude or stretch factor like that. All right, so there is this graph, and we are moseying along. There are 24 total problems, and the only other new thing that I have to employ, other than maybe a new kind of way that something has to shift, is what happens when B interacts with H. Especially because, listen, I couldn't edit these problems. If I did, I would have put an X in parentheses, and I didn't just change this problem. My OCD didn't kick in. But especially because they never factor out the B. So you'll get some practice with me on the few problems that we're going to have where we have to factor out a B to make everything as legit as it's supposed to be. I'm going to let my OCD kick in because I reminded myself. This will be y equals 2 times cosine of x plus pi over 2. Literally no change other than putting in an x. Maybe that's why it's not so much a problem because they put parentheses. All right, no horizontal shift. Your midline is at y equals 0. That is not y equals 0. Let's get there. This is cosine, so we are going to start not 1 above, but 2 above at that proper horizontal shift. So instead of starting right here, let's shift pi over 2 units to the left, right there. This is where we're going to start. Amplitude is 2. Period is 2 pi, so every pi over 2 units we hit another critical point, such as going down to the midline, and then the trough, midline, crest, midline. And we just work from there. So there's a shift. This graph, and here's the thing, I've mentioned this before, sine and cosine graphs are the same. I mean, there's a new starting point, whatever. Same period, same oscillating things, same like that. There is a sine graph that's equivalent to this that I could have made. I'll write exactly what that equation could have been. That's something we could, sometimes have fun with. It would be kind of a cool test question, like write a sine function graph that's equivalent to this. The sine graph equivalent to this, and there's more than one because you can make any shift you want, but this one have had to shift. Midline, point at the midline with no shift, amplitude of 2, and goes down instead of up. This would have been y equals negative 2 times sine of x. This is the exact same graph. Go to a graphing calculator. See what happens. This is the exact same graph as that one right there. Kind of cool how that thing just works like that. I wish I gave you some negative ones. I didn't, but I wish I did. But that would have been the same thing. Okay. How's our time? Yeah, probably not going to beat the hour, although there are only 8 more problems. 2/3 of the way through. Most of the stuff has been conquered. Let's just change this to an X like that. Sound good? Okay. All right, your midline is at -2, y equals -2. So this is where we shift this height vertically. This plus 3 pi over 4 means it's a left shift, 3 pi over 4 units. It's a sine graph. Will be on the midline. 1 pi over 4, 2 pi over 4, 3 pi over 4 to the left. Your amplitude is 1, so every pi over 2 years, we're going to hit a new, and a new right here. Looking good. That's it. I mean, I don't have more to say once you start, and once you start to understand the process of what's going on, it really is a bit of a, I mean, like I said, I haven't done this in 5 or 6 years. It hasn't changed what you're doing with them. I know how to do my trig, and I know what they're supposed to look like. Here's the thing. We haven't done tangent and stuff yet, So, tangent doesn't look like these. Tangent's a little weird. Tangent asks a little more of you. Maybe. It depends on how particular I'm going to ask you to get. It depends on the problems that we see. I'm probably going to generate them from CUDA, where you have theta. Speaking of theta, let's turn it to an x. All right, cosine of this plus 1. Don't mind if I do. The amplitude is 1. It is cosine. We will be above the graph, 1 to start. However, we will be shifted 5 pi over 4 units to the right. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. The frequency is 1, so every pi over 2 units, we hit another bit right there. Can't really hit this other one. Like, it's kind of far out, but just knowing that it goes kind of down there is going to be nice to draw out. So here, we're hitting these parts. Every pi over 2 is every 2 pi over 4s, right? So it might be worth your investment. Again, we talk about period. Period is 2 pi over 1, which is 2 pi. But if we divide 2 pi by 4, I mean, yes, it's pi over 2, right? We mentioned that. But it's also 2 pi over 4s. This is what I wanted to bring up. That's how far over you go before another thing. 1 pi over 4, 2 pi over 4. Boom. Hit another part. 1 pi over 4, 2 pi over 4. Boom. There's another part. So that's kind of where we're hitting those bits right there. And yeah, let's go ahead and finish that one off, as this should curve back up. Okay. All right. So there's that. All right, we got 6 more problems here, and let's see what they get into. No real change here yet. There's still, yeah. It's actually not until we hit 22 through 24 that we have B with H. I think these are just H's with A's and K's, and making sure we got those. So listen, I'm gonna work pretty fast on these ones here. You got a midline of -1. This is cosine. Notice cosine is now on the left side. I don't know why I have that, but cosine is now on the left side and sine is on the right side. This is a cosine graph, so we will be with an amplitude. We'll be 2 above the midline, pi over 4 units to the right. Pi over 4 units to the right. Frequency is still 1 right here, so every pi over 2 units will hit another bit. Boom, boom, boom. Looks good. And then boom, 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 and boom, like that. I only trust that with the speed I'm doing these, that they're all being done correctly. I think the time that these take to be a while is if you had to make your own graph and scales. That's really where it would take some time. If your scales aren't lined up with what you're doing, or just drawing this curve. Everything else, man, if you know what you're doing, it's no problem. Especially if you have a little line tool to draw the midline. That is just fancy. All right, 1/2 and sine right here. 7 pi over 4. I don't even know if I can reach that here. Oh, it looks like I probably can. But the midline is -2, so get that midline going right there. I got a 1/2 stretch factor, or an amplitude right here. I'm going to start on the midline, but 7 pi over 4 units to the right. You know how far that is? I think it's here, but 1, 2, 3, 4, 5, 6, 7 pi over 4 units over there to the right. Honestly, I can't even reach points over here. which is fine. I'll kind of simulate where it is, but the point is you still want to know where it is because you want to know which direction you want to go. Do you go to the left, do you go down, or do you go up? And as all these are positive, if we're going to the right up, then we're going left down. So there's that. Now your amplitude is 1/2. So generally we would have gone, we probably would have hit about right there at pi over 2 units over. So another pi over 2 units over this way, we're going to be hitting a 1/2 down right there before we go back up. And up, and down, and down, and up, and up, and somewhere back down there. Okay, so let's complete that. Yeah, definitely, man, I really, especially with cosine, well, with both, I'm really eating away at the fact that none of these are negative. And it takes nothing to just change one of these negative when I can, but I can't account for what problems my students might do, before that. And it's like, well, now they have to erase theirs, or they don't. They did their attempt at their thing. We'll deal with negatives, I guess, a different day for my own kiddos. All right, last one before we get a little tricky. All right, so 3 times cosine minus 2. So we got a midline of -2 right here. Midline of -2 right there. It is a cosine graph. We are going to start above the midline. With an amplitude of 3, we'll be starting 3 above the midline. But because it is, instead of right here, because of the plus pi over 4, we're going to be pi over 4 units to the left, right there, just like that. Frequency is 1. So period is 2 pi. So every pi over 2 units, we're going to hit another spot, which is right here. So the last untricky problem when it comes to setup, I say untricky, I don't know where you guys are sitting with this material here, but lots and lots and lots of problems. Never hurt nobody to practice and try and make sure you're really getting it good. You're getting this figured out the right way. Okay, the difference with these next problems here is there is a B and an H. But the H is not its true H just yet. And this is where, never mind theta, these problems should be rewritten. Because I'll tell you what, here's the problem. H is not pi over 4. We are not going to shift this thing pi over 4 units to the right. Because it is not H. Because the true form right here, the true form of these is B factored out. This isn't the first time you've seen this. You've seen this with maybe with quadratics and cubics, but we've done even more for those. We've seen it with square root functions. We've seen it with cube root functions. We'd also pull them out. Its true H form is not unless your B value is factored. Now the first one's a little tricky in and of itself because your B isn't 4, it's 1/4. As a first rewrite of this, I can say y equals 1/2. A lot of fractions here. Y equals 1/2 times sine. Keep in mind, it's going to stay inside of the sine function. Minus pi over 4. Whoa, minus 1. That over 4 is a 1/4 right there, okay? That 1/4 is not, it is B. I'll tell you what, it is B. But this isn't H yet because this B isn't factored out of this quantity. We have to factor, and this is where we're going to get my finished product. We have to factor a 1/4 out. Let me do this again. Square brackets. We have to factor a 1/4 out of this part right here. Now, this isn't hard. 1/4 times what is negative pi over 4? Well, negative pi, right? You're asking what would I have to distribute into here? Look at this. What would I have to distribute into here to get this? Well, that makes sense. Pi over 1/4 times pi is pi over 4. So that's what you would distribute to get in there, and that's what happens when you factor it out. When you factor out a 4, everything becomes 4 times smaller. When you factor out a 1/4, everything becomes 4 times larger. And that's what this is here. This is your true H value. And that's what makes that thing a little bit more difficult there. And we're not done with this because now we have a frequency to have to deal with. And so let's go. And this is with everything. There's an A, a B, an H, and a K. And I'm excited for some reason. Brand new exciting video, ladies and gentlemen. It's an honor and a privilege to serve you here. All right. Maybe we can crack these in 5 minutes, but I doubt it. I could. But we're going to work on this together here. Let's kind of draw out what these are. Your A is 1/2. Your B is 1/4. Now we got to determine the period based on that still. The H is pi. Remember, not negative pi, but pi. And the K is -1. The K being -1 is your midline. That is where we're going to start. Y equals -1. This is a sine graph. That means we will be on the midline to begin with, but we have to also horizontally shift pi units over. We're going to start, and by the way, here's 2 pi. We're going to start at pi right there. There we go. That's pi. Now the frequency is next. This is where the 1/4 comes into play. Excuse me, the period with the frequency. The period is 2 pi over your frequency of 1/4. 2 pi times 4 is 8 pi. It takes 8 pi units to complete a full cycle, to go all the way from peak to midline to trough to midline, all the way back. If you divide 8 pi by 4 into its increments, all those are 2 pi's, right? Divided by 4, you get 2 pi. Every 2 pi units, we're going to do a new thing. Now, 1/2 is your amplitude, so we're going to hit a 1/2 up and down every 2 pi units. So here's 1 pi, 2 pi, boom. We're going to go up 1/2. 1 pi, 2 pi, boom, midline. 1 pi, 2 pi, down there, you can't really fit it. And then we would have hit midline again, and we have completed a full cycle. That's 8 pi units later. What's 8 pi away from pi? 9 pi, and that's where we would have gone. So here's 1, 2 pi over here where we go down. 1, 2 pi over here where we hit midline. 1, 2 pi at peak. 1, 2 pi here at negative 7 pi, which is also 8 pi away from pi right there. And there's that sine graph again. No negatives. Oh my goodness. Oh my goodness, that is terrible looking drawing. Okay. This is why it's going to not spend 5 minutes. You know what? That was the best looking one, and it still isn't great. I'm just going to go ahead and do that. Yeah, all them fractions, though. Way to get you started off on that. Maybe these next 2 we can whirly bird this thing and get them in kind of fast. Maybe, maybe not. Depends on the numbers. Okay. Not good looking. All right. 2 more. Number 23, number 24. Once again, they didn't start any of these things factored. Boo hiss, we're going to have to deal with it. So, to start off with, well, I'm going to start up straight up. I'm going to factor a 2 out of this quantity here, right? 2 times what is that? Dividing a fraction by 2 is multiplying it by 1/2. Why do I say that? Because we need to turn that 3 pi over 2. Oh my goodness, hold on. Because we have to turn that 3 pi over 2 into 3 pi over 4. When I factored this 2 out, not to reveal the b, I reveal the h, the true h value. If I distribute this back in, 2 times 3 pi over 4 is 3 pi over 2. Pi over 4 is half of pi over 2. We know that. So 3 pi over 4 is half of 3 pi over 2. This is the true value of everything that we need here. Your a, b, h, which is negative, and k, which is positive. And we're going to start there at that plus 2. Let's work from that plus 2. Y equals 2 right there. This is a cosine graph. This is a 4 amplitude here. Now, the 3 pi, not 3 pi over 2, but 3 pi over 4 is how far we will go left. Yes, plus is left in this case. How far we will go left from there as we also start 4 up. Let's think about it this way. Normally we'd start up 1, 2, 3, 4 right here. But we got to shift left 3 pi over 4 units. So here's 1 pi over 4, 2 pi over 4, because that's a pi over 2. 3 pi over 4. This is where we'll start. I really wish there were negatives. The 2 is your frequency. Your period is going to be 2 pi over 2, which is pi. So it completes a full period in pi radians. That means pi over 4 is every quadrantal bit that you're going to hit another part there. So every pi over 4 radians, which these are literally pi over 4s right here. Pi over 4, pi over 4, pi over 4, pi over 4. So every time we'll hit a new critical point as we go down to the midline. And then 1, 2, 3, 4. Down to the trough. Back up to the midline. Back up to the peak. Down to the midline. I feel like I'm saying something to my little baby nephew. Down to the midline. Up to. And yes, that continues there. Very, very, very pretty. Very beautiful. Okay. Okay. I got one more for y'all. I don't know if it's easier or harder. But let's finish this one off right here. Okay. Not bad. Not bad at all. Actually, it's pretty good. All right. Last one. Y equals 2 times sine of theta over 3 plus 7 pi over 6 minus 2. Yeah, it looks a little heinous. All right. Let me first write it up here, and I'll drag it down. 2 times sine. I'm going to write the 1/3 out in front. I haven't factored yet. Okay, let's bring this down here. We got to factor that 1/3 out, though, which does mean make your other thing 3 times larger than it is now. This guy, 3 times larger, makes the denominator 3 times smaller. These are the little bits that aren't emphasized enough in older math classes. Being comfortable with dealing fractions the right way. As you're working this new material, you're probably sitting here saying, why does this become 7 pi over 2? I mean, honestly, when you see the reverse in terms of distribution, I think you can agree and understand why that is. 1/3 times 7 pi over 2, 3 times 2 is 6. But the factoring out notion, that factoring out a third makes it 3 times larger, and that makes the denominator 3 times smaller, really throws a wrinkle in people's minds for that one. So it can become a bit cumbersome for people. People can have some trouble with that for sure. All right, so there is that. This is a sine graph. There's our midline at -2, but this is the graph I'll be working off of. So let me kind of box it up and take it to go. So let's see here. I don't really know where to put it. Let's wipe this other one out. We don't need you no more. We done with you. Bye. All right. Here's our new. Here's our new right there. Missed the hour mark. That's okay. All right, -2, 2 down. Right here. All right, 2 down. It is a sine graph. We will start on the midline. What part of the midline? 7 pi over 2 units to the left. 7 pi over 2 is halfway in between these. So this is something else we do have to deal with here. And let's see. Here's 1 pi over 2. I mean, I'm going to do slowly with you. I know where it is. But 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. And it is on the midline because it is a sine graph. That is where you're taking the sine of 0, basically. Right? That's what's going on. This 2 is your amplitude here. It's positive like they all are. So we'll go up instead of down. But we have to talk about the period right here. Excuse me, the frequency based on the period based on the frequency. 2 pi over 1/3. That's 6 pi. Hope you know why that is. Okay, hopefully this one's not dreadful as far as working things out. Here's a good talk to kind of mention. When you divide 6 pi by 4, you get 3 pi over 2. So every 3 pi over 2 radians, you are going to hit a new peak or trough and stuff. So, okay, we did save the hardest problem for last. This one has some things to do. It's not bad. It's not bad. We already counted our pi over 2s to start with here. It's halfway in between these, right? They're halves. So we'll go 1 pi over 2, 2 pi over 2, 3 pi over 2 for us to hit our peak. 1, 2, 3 pi over 2 to hit the midline. 1, 2, 3 pi over 2 to hit the trough. 1, 2, 3 pi over 2 to hit the midline. 1, 2, 3 pi over 2 to hit the peak again. 1, 2, 3 pi over 2 to go road to nowhere. 1, 2, 3 pi over 2 is right down. Sure. So there is this graph right here. It should be good enough when it comes to what's going on there. Remember, pi over 2s are halfway between pi's there. Was I missing anything? I don't think so. We took care of the shift, both horizontally and vertically. We took care of the amplitude, which is on that scale there. Nothing was negative to my dismay, but of course it just flips it over. There's not much on that. It's just we gotta practice those too, right? We practice everything else, we might as well practice that. And that's where that stuff gets a little tricky. I can see where you can see where things get a little confusing. If you think you have any dispute on any of these or you're not sure, go into a graphing calculator, see how they look. They should be fine. Okay, guys, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching on these 24 different problems. Next time you see me do some of these, we'll have tangents. Next time you see me do sine and cosine, I got to be sure to include some negatives, maybe some where x is already involved and where maybe some b's are already factored out. But everything I hit on, outside of maybe having us to scale all our graphs, everything I hit on is the minimum of what you would probably need for these things anyway. It's not too much. We're not asking you for all the in-betweens, just peaks, troughs, and midlines. And then that's it. That'll do it for this one, guys. This is Mr. Robinson. Thank you so much for watching. Take care. I will see you in the next one.